Welcome back to the Advanced Microcontroller series. In previous session we discussed about UART polling method. But why it is polling? Let's see now. So this is the code for UART polling method. So here you can see we having two functions, getChar and putChar. So in the getChar function we having a while loop, and in the putChar function we having do while loop. So why it is used? So it is continuously monitoring till the transmission complete, and in getChar function we having while loop, right? So why it is used? It is used to make sure data is received or not. So here also we using polling method. So if we are using polling method, it has some disadvantages. So what are the disadvantages? Let's see now. So here you can see we having this getChar and putChar function. So we receiving some character and we transmitting back the same. So after that if I write any code, so the code will block here. So let's see how it will block. So before that, why it is blocked? It will block due to the polling method. How? Let's see. So here I am going to write the code for toggling LED. So before that, here I need to define, isn't it? So hash define LED1 is equals to RD0. So here I am going to use port D and I am clearing tris D. Why? Because LED is a output device, isn't it? Then port D, initially I am considering LED is turn off. So here also I need to add a semicolon. So then after that, here I am going to write a code for toggling LED. So LED1 is equals to not of LED1. This code is written for toggling LED. But are we able to see the toggling? So it will happen in very faster way, isn't it? So we are not able to capture. So what we have to do? We have to add some delay. So for that I am going to declare one variable unsigned int wait, and initially I am considering this equals to 0, and here I am going to write a delay which is for non-blocking delay. Okay, if wait minus minus is equals to 0, then what will happen? LED toggling. So after that wait equals to 50,000, then this will end. So this block will end. So initially it will check the condition. So initially wait equals to 0, right? So wait equals to 0, condition true, LED toggles, then wait equals to 50,000. So this is what post decrement. It will check the condition first, then it will decrement. So now wait is equals to 50,000. Wait is not equals to 0. Wait is equals to 50,000. So then condition fails. It will come out of the loop. So after checking condition it will decrement, right? So 50,000 decrement means 49,999. Again it will check the condition. It will false. It will come out of the loop. So again it will check the condition. It's false. It decrement, then come out of the loop. Same thing happens till it reaches to 0. So when it reaches to 0, LED starts toggling. So after 50k iteration, LED is going to toggle. So let's see the output now. So before that I am going to comment these two lines and let's see the output. build and go to the PICSimLab and here load hexa file. So here you can see LED is toggling. Now uncommit these two lines and let's check the output. So here click build, go to the PICSimLab and click reload last. Okay, let me rebuild it, clean and build. So here file reload last, you can see that there is no output. Why LED is not toggling? So okay, let me check using QtCom. Let me clear the previous outputs and here also let me clear. So before that we have to set the same baud rate, same data bits, whatever we already set it, right, for PICSimLab. Same thing here we need to set, and here you need to select the odd COM ports and here you need to select the even port. Then click open. Now again either click reload last or here reset. Now in the QtCom see whether you got this or not. Yes, code is running, but why you are not getting output? So why LED is not toggling? Let's see now. So here you can see this is our main function. So control will go to the init config. So here it will do the initialization, then this initialization, then it will execute the puttest function. It is executed, right? We verified whether it is executed or not. We got the output of puttest in the QtCom. Then after that it will come here in the while loop. So while loop is started. Now it's executing the getChar function. So it came here. So here microcontroller is executing getChar function to receive a character from the serial application. So in getChar function while loop is called. Are we receiving any character now? No, right? Because we didn't transmit. So we are not receiving any character now. So what will happen? This condition remains true. The flag will remain 0. So when flag will become 1 only if you are receive a character. So due to this polling method, you are calling getChar function and unless and until you are receiving a character. So here this line. So we blocked in this polling method. So code is not executing because of this polling method. So when you will come out of the loop, so as soon as you receive a character, so here let me transmit some character in QtCom. So I am going to transmit this character. Now I received, isn't it? So next time what will happen? Flag 0. Now flag is 0. So it will come out of the loop. So ch equals to x. Now LED start toggling in PICSimLab. So LED here you can see. So once condition true, then what will happen? Ch equals to 0, right? Then it will come here. So initially it is 0, then LED toggling, then it will come out of the loop. After that weight equals to 50,000. So condition false. Next again while loop control will go to the getChar, then polling method. So now again I transmitted y, then z. So let's see what will happen. So now again I will transmit y, then I am going to transmit z. I received. But in the PICSimLab, here, see here, LED is not toggling, it's on only. So in the code, getChar is received, right? GetChar executed, character received. So what will happen in the getChar? It will come out of the loop. And here in the putChar function, so in the putChar, here you can see in the putChar same data writing back, isn't it? And so here what will happen, it will check if condition is true or not. So initially it is 0, LED toggle, then weight equals to 50,000, so condition fails, isn't it? So it is going to decrement, then it is equals to 49,999, again condition fails. Then here we transmitted Z. Now here weight is, again it will check the condition, so weight is false, it is equals to 49,998, again condition fails. We have received 50,000 iteration, after that weight will, so to toggle the LED we need to receive 50,000, we have to do the 50,000 iteration. So after that weight becomes 0, then LED starts toggling. So this is the drawback of polling. So instead of polling method in reception, let's generate interrupt method. So whenever receiving the data, we will generate the interrupt. So receive interrupt, that is nothing but receive interrupt. So this interrupt going to set where, here in the receive, right? So this interrupt going to set the flag RCIF is equals to 1. So let's discuss about UART. This is what polling method, right? We are going to discuss about the interrupt method. So let me close this polling method. So since we using interrupt on reception, we need to enable the receive interrupt. So let's see that one. So here you can see we having RCIF. So what do you mean by RCIF? That is receive interrupt. So with respect to this, every interrupt is there, right? So with respect to this, every interrupt there is a 2-bit to enable it. So this is what, this is a individual bit. So by using receive interrupt enable, we are enabling the interrupt. So here you can see what we having here, GIE equals to 1. So why it is used? It is used to enable the global interrupt and peripheral. So here you can see GIE equals to 1, and for peripheral here we having PEIE equals to 1. And here you can see we are executing putChar function, and here you can see the same logic we are using for putChar function, isn't it? So here you can see while of 1 we having, and same function for putChar function. So now you are busy executing while of 1, and this if block is there, right? So this block busy toggling LED. So while executing this we got an interrupt on reception of data. So UART block generate a interrupt on reception of data. In that time, control will go to ISR. So control will come to here. So here global declaration of variable is done. So here you can see unsigned char ch. So all the interrupt using same ISR. So whenever data is received, this flag is equals to 1. So this data will receive buffer register. So that is what RCREG. So here we reading the received data from buffer register and storing into the variable ch. So before coming out of the ISR for next line C, here we clearing the flag bit. So now control will come out of the function or come out of the loop. Then here you can see in the main function. So assume I transmitted data which is equals to x. So here ch equals to x. Now data is equals to x. So whatever data we received, we have to transmit the same, isn't it? But here you can see ch belongs to ISR block. We define it as a variable. Can we use ch here also in the main.c? Yes, we can use, but we have to do the extern. So here you can see extern unsigned char ch. So now it will keep executing putchar function and also keep toggling LED. So in this code we are not blocked anywhere like polling code. So all issues are solved this interrupt code. So assume if nothing is received, then what is the value of ch variable? Ch variable is updated only if you receive the byte. So it is a global variable. If there is no data is received, if no data is received, then what will be the initial value of ch? That is 0, right? It is a null character. So while executing the while loop, so assume, so if chr is equals to 0, so while executing the while loop, putchar is executed. So then what this putchar is transmitted? Null character. Then LED toggling. So to prevent that, here we having one line ch not equals to null character. So otherwise what will happen? Putchar transmit null character, then again LED toggling. If there is no need of transmitting null character, right? So here we added a condition ch not equals to 0. If ch value not equals to null character, then only it keep transmitting. So that's why here we added this. Okay. So otherwise what will happen? Here ch is received, then ch equals to 0. Then LED toggling, then again it will come here ch is not received, that is what? The same character. So if I transmitted x, that is x only. So the same thing, it will again tell I received x only. Again LED toggling, then again it will come, it says x only because it is not received, right? So here we added a condition ch is not equals to null character, and after this function here what we are doing, we are saying that ch is equals to null value. CH is equals to 0. So then it will come out of the toggle LED, then here CH is equals to 0. If it is not received anything, CH is equals to 0. Then if CH is equals to 0, it will not go into this loop. If CH is not equals to 0, then only it will go into this loop. So did you get? So if this condition is not true, it's not executing anything, only executing LED code. So when you are busy executing this interrupt, generate CH value, then update it. And if block condition true, whatever character is there that is transmitted, then executed the below LED code. And next time there is no reception, CH equals to X only. Already one time we received the character X. So again it prints X. Then it is it right? No, right? So here we added CH equals to 0. Once it is received, here we added CH equals to 0. Now if we not receive data, it will not going to transmit the previous data. So now let's see the output. So here clean and build. So now build is successful. Now come to the PICSimLab, reload last, and here we got UART test code. So and also here you can see so LED toggles or not. So LED isn't toggling, right? So okay, let's transmit X. We transmitted X and also we received X. So here you can see LED is on. Now again I transmit one more character Y. Now again I received the character Y. So now let me transmit some string. So I am going to transmit hello. You can see I received hello. So now I am going to transmit some big word embedded. See, I received embedded. So whatever data I have transmitted, the same data received here, then it will transmit back to the QtCon and it will receive here. So for Windows application, this there may be some issues in the QtCom. I don't know whether you having issue or not. When passing string, you can check whether the same output you got here also. And this is about the transmitting and receiving data using the interrupt method. Now another serial application is there, that is nothing but mini com, which is used for the Ubuntu, and for Windows you can go with the Teratom. Okay, you can use same thing and see the output using that one. So let's check that also. Sorry. So I am having that serial application also, this one Minicom. Why it's not opening? I think it has some issue with that. So no problem, you can set with install and set with the same, otherwise you can go with the QtCom only. Okay, that's all about the interrupt method, UART interrupt method. So same thing in Teraterm and Minicom also, there is no other difference. You can install it and check the output. So now let's talk about the another protocol, which is nothing but SPI. SPI is nothing but what? Serial Peripheral Interface. So UART is a inter-board protocol. So we are communicating between the boards, right? Between two systems. But SPI is a intra-board protocol. So here we communication between ICs or chips. So which is being placed on the same board. And this SPI is developed by the company Motorola. And here is the agenda: introduction, interface, hardware configuration, data transmission, in that data validity. And SPI means Serial Peripheral Interface. So it is a synchronous serial communication protocol. So communication happens with respect to clock. So there is a clock line. So that's why it is synchronous. Synchronous means we are using clock lines, and use it for high speed data transfer between a controller and one or more peripherals. So it is a synchronous communication protocol. And always there is a master and slave. So master is going to generate clock with respect to that clock line that data transmission happens. And this is a full duplex communication mode. So due to the full duplexity, how many data lines necessary, or how many data lines this protocol should have? Let's see that. So communication happens between two ICs or two chips in this SPI protocol. And two-way communication means full duplexity communication. So here both parties can communicate at the same time because of this. And they should have two data lines. So here it supports two-way communication, right? So it should have two lines. So which are the two lines? They should have two data lines. One is for transmission and one is for reception. And here we use the terminology master and slave. So one line is clock line, other two line is data line. And we can refer the device is master and slave. So this SPI protocol is a single master and multiple slave protocol. So SPI protocol is a single master. So here you can see master is single and slave is multiple. So this SPI protocol is a single master multiple slave protocol. So if a master can communicate with the multiple slaves, don't you think master have to select a particular slave? So for this we having one more line, that is slave select line. Apart from clock and data line, we having one more line, that is nothing but slave select line. So this line help the master to select the slave with which it want to communicate. So this is about the interface. So what we discussed, one is the clock line. So that is nothing but SCLK, means serial clock. And here you can see MOSI and MISO, master out, slave in, master in, slave out. And also this slave select line we having. MOSI means master out, slave in, MISO means master in, slave out. And this NSS means slave selection line. So these names are given by SPI standard. And here you can see hardware configuration. So here there is a single master and single slave. So who is going to communicate with the single slave? Master is, isn't it? Master is the one who is going to communicate with the slave. And here you can see SS1. What do you mean by SS1? Here what we discussed, there is one more line NSS, but here you can see SS1. So slave select line, this also say slave select line. So N means what? N stands for numbering. Okay, so this is what? First slave select line. So if it has two slave select line, then it should be SS2. That is depending on the number of slaves selecting network. Okay, so very first line. So here you can see we having a clock line. The clock line is always being generated by master, and that line going from master to slave. See the arrow, it going from master to slave. And next is the MOSI, master out, slave in. So master is giving the data and slave is receiving it. So see the arrow here also. All the data from the master is going to slave. That's why the direction of master, that's why the direction like this, from master to slave. But in case of MISO it is ulta. Here you can see it coming from the slave to master. And next is the slave select line, SS1. So there is only one slave, so SS1. Now master is going to communicate with the slave 1, and hence the direction is like this. So these are the 4 lines of SPI protocol. Any communication happens in SPI protocol should have these lines. And this protocol is capable of doing single master and multiple slave communication. For this we have slave, we have to select particular slave for the communication. So master is nothing but a microcontroller who have clock line generated. And what can be slave? There are multiple devices who can be a slave. For example, EEPROM, TAC, RTC, temperature sensor, flash memory. So let's see the single master and 3 slave configuration. So here you can see single master and 3 slave configuration. So here we having single master and slaves are multiple. So here we having 3 slaves. So master is going to generate clock line, hence it is only one clock line which is been commonly shared to all the slaves. So here you can see it is commonly shared, right, to all the slaves. So all 3 slaves means slave 1, slave 2, slave 3, and here you can see all 3 slaves are using the same clock line, common clock line. And next is the MOSI, master out, slave in. So it is going to communicate with the multiple slaves. So the common connection of MOSI. So here you can see MOSI is connected to slave 1, then same connected to slave 2 and slave 3. So here also common connection. So MOSI of master is going to MOSI of slave 1, also slave 2 and slave 3. So whenever slave has to transmit, master has to receive, we'll make use of this line. And here we having 3 slaves. So because of this we having 3 slaves, slave select lines. So here you can see SS1, SS2 and SS0, SS1, SS2 and SS3. It should be what? 3. So here it should be 3. Okay, SS1, SS2 and SS3. So now for example, I want to select particular slave. So let's say master wants to communicate with the slave 3. So how is the communication happening? So with the help of slave SS3. SS3 means slave select line, right? I want to communicate with slave 3, then I need to use SS3. I need to take a help of SS3. So it is going to select particular slave. So it is going to select slave 3. Now, so here you can see I don't want to communicate with slave 1 and slave 2. I can directly communicate with the slave 3. So we can see this as point-to-point communication. So here point-to-point communication happens between master and slave 3 with the help of SS3, isn't it? So slave 3 is selected when slave 3, so when we are going to use SS3. So SS3 is going to select the slave 3. And communication is happen between master and slave 3. So there is no communication happening with slave 1 and slave 2. The communication is happen between only master and slave 3. So whatever data is being transmitted by master is going to slave 3. So whatever slave 3 is transmitting is being going to the master directly. So by using slave select line, you can select particular slave and you can do point-to-point communication directly. If I want to select slave 1, then make use of this SS1 line, slave select line, SS1 line. So I am going to select slave 1 and communication happens only between master and slave 1. There is no communication between slave 2 and slave 3. And same thing happen in case of slave 2 also. So this is how single master is going to communicate with the multiple slave with the help of slave select bit. But here we having one potential issue with respect to this configuration. So what will happen if we have 100 slaves? We require 100 slave select lines, isn't it? So because of this, number of wire increases and the number of hardware complexity also going to increase. So this is an issue from the hardware side. So due to this disadvantage, we having other configuration, that is what? Daisy chain configuration. So here also single master which is going to communicate with the multiple slave. So here we having 3 slaves. But here we using daisy chain configuration. But what do you mean by daisy chain configuration? Do you know? So what do you mean by daisy chain configuration? So here you can see this flower which is connected from this to this, but this is the perfect example. So here you can see this flower is connected to this, then this, then this, then this, like this it is connected, right? The same thing here. in the daisy chain configuration. So here also it is connected the same way. Let's see how. So how the flowers are connected one to other, similar to that we have daisy chain configuration, and this protocol supports single master and multiple slave. So here we having only one master, and that master is like a owner who generate a clock cycle. So master generates the clock, and hence it is a common line. So clock line is common. So why it is like a flower connection, I will tell later. So before that, here you can see the clock line which is connected commonly to all the slaves. And we having next is the MOSI, means what? MOSC, master out slave in. Now here you can see MOSI of master is connected to slave 1, and here you can see this is what MISO, right? MISO of slave 1 which is connected to where? MOSI of slave 2, and MISO of slave 2 is connected MOSI of slave 3, and MISO of slave 3 is connected back to master. So it is like a flower. So master, the MOSI of master is connected to slave 1, MISO of slave 1 is connected to slave 2, then MISO of slave 1 connected to MOSI of slave 2, MISO of slave 2 is connected to MOSI of slave 3, and MISO of slave 3 is connected to this master. It is like how flower is connected in that image. The same thing, isn't it? The same thing it is connected. So between the master and slave there is a cascade connection, and these slaves are connected in a daisy chain connection, and here we having only one slave select line, that is SS1. Here you can see in the previous case we having 3 slave select line, but here we having only one slave select line. It doesn't matter how many slaves are there in network. So what is the issue we having in the previous configuration? That issue is resolved here. If number of slave is increasing, then number of slave select line also increasing, and wiring also increase, and for that hardware configuration is difficult. But here we having only one slave select line which is common for all slaves, but here we can't specifically select a line. So when data transmission happening, whatever data is there in master, first it comes to slave 1, then slave 1 to slave 2, then slave 2 to slave 3, then slave 3 back from slave 3 to the master. So for example, master wants to communicate with the slave 2. So here is the slave 2. So how it will communicate? Is it going to communicate directly? No, it is not going to communicate directly. So if master wants to transmit some data to slave 2, it first have to transmit to slave 1. So it will transmit to slave 1. Then from slave 1 to slave 2, it will transmit the data. This is the one issue. So if slave wants to give the data to master, then how it will do? Now slave 1 have to give the data to master, then how it will give? The slave 1 have to give it to slave 2, then slave 2 have to give it to slave 3, then this slave 3 will give it to master. This is the disadvantage. So here we having disadvantage. There is no point-to-point communication here. You can't select specific slave to the configuration. So this is the disadvantage we having. So here you can see single master, single slave communication. This is single master, 3 slave. This is normal configuration and this is the daisy chain configuration. And here you can see data transmission. So let's see this slide in the next session. That's all about the today's session. Thank you all.